Hello friends, welcome back to session 7 of DevOps series. So in the previous sessions we have covered the multiple topics like the introduction to DevOps, then CI/CD, high availability, networking concepts, CIDR, then containers. Okay, in this session we are going to cover the introduction to Kubernetes, which is one of the very important and critical component in DevOps, specifically from the infrastructure side. Okay, so what we have learned so far about the containers, that container is a package which contain your complete softwares, applications, and the dependencies, right? This we have covered in very detail in the previous sessions. Right, and Docker is one of the leading containerized solutions. There are multiple others as well, but Docker is one of the important or critical containerized solution that you will see at the multiple places in the multiple professional environments. Right now, but with the Docker or specifically with the containerized technologies, we have multiple challenges, and to solve those challenges, the Kubernetes came in the picture. Okay, so now first it is important to understand what all are the challenges that we have with the containerized solution, and then how Kubernetes solve that problems. Right. So now let us suppose that in one of our environment, okay, we have multiple containers. For example, we have a two containers, or maybe we have a four containers. Right. And now we have a multiple things, specifically in the live or production environment, with respect to the run and maintenance, right, which is called the continuous support of your applications. So now instead of the installation of the software applications and configurations, what we do, we just do the deployment of the containers. Right, we have one container which contain all of our softwares, application, dependencies, and everything, and we just need to roll out the containers in the different virtual machines. Right, so it is now the hardcore dependency of the installation of the software applications and then your dependencies, integrations, that is eliminated with the help of containers. That is one of the big benefit that we have got with the help of containers. Okay, now but if the number of containers is increased in the environment, okay, if you have only one container or two container, that is easy to manage. Whether it is, you can say, you are going for the rollout of the new deployment of the new applications, or any kind of a configuration changes, or there are multiple other things that I am going to explain you. Okay, so it is easy, but when the number of containers get increased in the environment, it is not easy to manage that. I will give you one example. For example, you need to roll out one of the new version of your application. So basically what we do in the containers, we have one master container which will contain your software, your application, your code and dependencies. So we update or we upgrade our this particular container, or basically we have image there that we are going to cover in detail in the Docker session. Okay, so we roll out one of the image, and the respective container is created based on the image. So that means we have a one golden image which is called the image, or you can consider as a golden container. Okay, this container need to roll out everywhere. Wherever we have the existing containers, that need to be replaced with the new container which contain your new configuration, or you can say new code. Right, or these containers may be running on the different servers, maybe different virtual machines or different physical servers. Right, these are the hardware layer which could be your VM. Right, and on top of VMs we are running multiple containers. Right, so now if you need to roll out, I'm giving you one of the example of just the deployment of a new container. Okay, so now if you need to roll out the new container, okay, or you can say you need to replace the existing containers with the new container which contain your upgraded code or the configurations. Okay, isn't it feasible, okay, to log into each and every virtual machine or server and then replace each and every containers manually? No, it is not feasible. Right, specifically in the production environment where we have an uncountable number of VMs and servers, where we have uncountable number of containers are running, it's not possible for you to just log into each and every VM and then you can replace each and every container by running the Docker or the containerized command to replace with the new container. It is not possible. Okay, it is very complex. It is going to take a lot of time. There could be a lot of situations where you encounter with the some manual problems or manual errors. Okay, so this is a challenging task. Similarly, this is one of the example I have given to you with respect to the deployment of the containers. Okay, but apart from that, there are a lot of other things as well that we need to take care, specifically when we are working in the environment where we have the multiple containers. Okay, so what are all those challenges? So let me quickly tell you one by one, and then I will tell you how the Kubernetes is going to solve that problem. Okay, so the first challenge that we have discussed about the deployment of new containers, or you can also say it is a rollout of new container, rollout of new containers. Correct. Similarly, after the rollout, you may have a term called rollback. Now, suppose that you have the multiple virtual machines or servers where the multiple containers are running. Okay. Now, you have manually logged into each and every virtual machine, and then you have roll out the new code. Now, suppose there is a problem with the code and you need to roll back. Then again, you have to follow the same process. You have to log into each and every virtual machine. Whatever the task that you have done for rollout, you have to follow for the rollback as well, right? Because you need to delete the existing containers, and that need to be replaced with the previous version, old version, right? So this is again a challenge. That means rollout and rollback is one of the biggest challenge when we have a multiple containers, right? Similarly, you need a certain solution to load balancing the request between multiple containers, right? You have a these are a multiple containers, and if some client is going to access the application, you need to load balance the request between the multiple containers, right? This is a concept that we have learned in the initial sessions, high availability. What is load balancing? So you need some solution to load balancing the request between the multiple containers, right, where your applications are running. Third, if suppose that one of the container or more than one containers are crashed or maybe not responding due to any reasons, okay, then you need a certain kind of a mechanism which automatically recover your containers which is failed. What does it mean? I have 50 containers. If any time one or more than one containers are not responding or crash due to any reasons, you need a certain solution, okay, which should automatically remove the container which is not responding or crashed, and instead of that spin up a new container, right, which is called the self healing feature. Okay, and then along with that you need a certain kind of a storage orchestration solution. That means you may have a certain kind of a data that need to be shared across the multiple containers, right? Multiple times you have a multiple configuration files, the multiple kind of a data that need to be shared across the container, so that you need something which allow you for the storage orchestration as well. That means to share the data between the multiple containers, right? So individually, when we talk about the Docker specifically or the containerized solution, all these features are not possible in the containerized solution. There are certain native tools as well that allow these some management of centralized management of the containers as well, but they have the limited some capabilities are very limited. Okay, they are not full-fledged functionalities which can be used in the production or live environment. So for that, to overcome all these situations, we need a solution, okay, which help you to manage end to end the containers that you have in your environment, and that is where the Kubernetes came in picture. Okay, so whatever the challenge that we have discussed so far, like the rollout and rollback of multiple containers, self healing, if any containers crashed, that you need to recover it automatically, right? Then load balancing of the request among the multiple containers, then storage orchestration, that means shared storage across the multiple containers. So for all these functionalities we use the Kubernetes, right? So now one thing is very clear. What is Kubernetes is an orchestration solution only. It is an orchestration solution only. That means it is going to multiple containers. Okay, so this is your virtual machine 1, this is your virtual machine 2, this is your virtual machine 3, and this is your virtual machine 4, and you have four containers running on each and every virtual machine. Now you need a centralized solution so that you can manage all the containers from a central location. For that you have the Kubernetes. Okay, so that's why it is called an orchestration solution for the containers, so that you can manage all the containers from a single location. So now how the Kubernetes is going to solve each and every problem? So from the Kubernetes, from a centralized single point of place, okay, you can allow the rollout of your containers. So what does it mean? When you initiate the rollout of your new containers from the Kubernetes, it will automatically reach to each and every virtual machine or server. It will automatically replace the containers one by one. You don't need to log into each and every virtual machine for the replacement. It will automatically log into each and every virtual machine. Okay, and it will automatically replace your old containers one by one with the new containers, and that is in the rolling fashion. Rolling fashion. That means there is no downtime of your application deployment, right? Because we are doing the deployment of containers, and it will be doing the deployment of containers one by one. That means the first container, once it is replaced successfully, then it will go to second containers. Once second is replaced successfully, then it will go for fourth, and then fifth, and then for the other containers on the other machine. So that means there is no downtime of your applications when you are going to roll out of the new code. Okay, and it will going to perform every changes in the rolling fashion, right? Similarly, for example, if you would like to roll back, right, there's a problem with the code and you would like to roll back the container, and the new container you would like to replace with the old container, right? So again, you can initiate the command from the Kubernetes centralized tool, and it will again, just like it has done the rollout of the new application where it has replaced the old containers with the new containers. Now it will replace the new container with the old containers one by one again in the rolling fashion without downtime, right? So this is one of the major benefit that you can achieve with the help of Kubernetes. Second, if any of the container is crashed in your cluster or your Kubernetes cluster, because whatever the containers that we have inside a Kubernetes, okay, we call it in a cluster. Okay, so whatever the container inside a cluster get crashed, the self-healing feature of your Kubernetes will automatically recover that one. That means if a container is crashed, okay, or maybe not responding, it will spin up a new container instead of that. So for example, if you have 15 containers or 50 containers in your cluster, Kubernetes cluster, and five containers are not responding or crash, it will automatically check the health of each and every containers in a regular interval. It will automatically spin up the five new containers for you. So this is called the self-healing feature. Then load balancing. So you have a multiple features or options are available in Kubernetes that we will cover in the detailed section once we reach the Kubernetes. Okay, so that components can automatically load balance the request between each and every containers in your Kubernetes cluster. So that means load balancing can also be achieved with the help of Kubernetes. Then storage orchestration. So you have the native feature in Kubernetes. With the help of that, you can configure a shared storage like the NFS we have, right, for some common configurations or attaching a particular disk to the multiple virtual machines or servers. Similarly, Kubernetes has a native feature. You can configure some directory as a shared directory which can be accessed from each and every container. So that is called the storage orchestration. So these are the different features that you can achieve with the help of Kubernetes, which is not possible in the containerized solution itself. So that means one thing is very clear: if you are using the Docker or any of the containerized solution, let me write it here. So if you are using any of the containerized solution, it is very important to use the Kubernetes as an orchestration solution to manage the multiple containers. Okay, so now how it works, let me quickly give you a few important terms that we have in the Kubernetes, how it Kubernetes work. However, we are going to cover this in detail in the later sessions when we cover the Kubernetes in execution. Okay, so how it works, as I said, your Kubernetes control everything from a centralized location. So we have one machine, okay, which we declare as a master node, which is also called the pane, control pane. Okay, this is the centralized location where your Kubernetes centralized components are running, which is going to manage the containers. Okay, and then we have a multiple virtual machines, right, where we have the containers are running. So this is the VM1, this is VM2, this is VM3, VM4, VM5, and on top of that we have a multiple containers are running on the virtual machines, right? So all these VMs where the containers are running is referred as worker node in the Kubernetes. Each virtual machine where the containers are running, which referred as worker node. Worker node. So we have a one master node, which is also called the control plane, okay, which is going to centrally manage all the containers from a single location, and here all the containers are running inside the worker nodes. And other important term that we may heard about the Kubernetes pod. So I saw that many engineers are confused on the pod. What actually is a pod in the Kubernetes? It's very simple. As I said, in each and every virtual machines, we have a multiple containers are running. So these containers we can group inside a pod. So pod is simple. It is a grouping of the containers. So if I am saying there is a pod, that means inside a pod there could be multiple containers are running based on their requirement. Either it could be one container or it could be more than one, two, three, any number of containers. So pod is a grouping of the containers. Right. So what we have learned about the Kubernetes. So Kubernetes is an orchestration tool that is used to manage the multiple containers. Then we have learned the multiple benefits of the using the Kubernetes and a basic architecture of Kubernetes, where we have a master node, which is also called the control plane. Then we have a worker node. Okay, worker node where our containers are running. Right. And then on top of that, we do the grouping of the containers. Okay, and this each group of the container is referred as pod in the Kubernetes. So hope now the Kubernetes concept is clear to you. Okay, so we are going to cover this in detail when we go for the lab session in the later time. Thank you.